Welcome to the third lecture from the DSIO notebook. In this video, we're going to talk about CSV files, which are among the simplest and most widespread file format for saving tabular data, meaning data arranged in the format of a table. We'll see that not all data is well represented by a table, but CSVs are commonly used for representing data that is stored in a table. This might come from a database or an Excel file, or just sometimes people just store data in CSVs. Like I said, it's a very common file format. So CSV stands for comma separated values. And if we open up in the data wrangling data directory CSV sample, we see what a CSV looks like on the page. So we have comma separated values. So each item in the header, for instance, is separated by a comma. Each row is separated by a comma. And the interpretation here is each new line is a row, and each item separated by a comma is in a different column. So you can see how this lines up into a table. We have the headers on the top. We have a column down the left-hand side, that's the index. We have another column holding names, and then another column holding ages. We can read that into Python just like any other text file. This is just text. And then once we've loaded it, we just have some strings, and it's up to us to parse the text into a particular data structure. And we'll see this as a theme repeated throughout our use of different file formats, is often the file will be represented in text. It will just be some text file, but the text file follows a particular structure and uses particular markers or symbols that we use to parse the text into a data structure. So with a CSV, those markers are the new line characters separating lines and the commas separating the different columns of the table. So if we wanted to parse this file, for instance, into something like a table, we could make a list of lists where our overall list represents the table, and each list within that represents a row in that table. And the elements of each row are the different columns. So here we'll have a list containing 4 sublists that each have 3 elements. So we'll initialize this list table. We'll open our file for reading, and for each line in the file, we'll append a row to that list table. And the row, we're going to strip out the new line characters or any extraneous white space, and then we'll split apart the string based on its commas. And we end up with a list of lists, just like I said, where we have 4 rows, and each row contains an index, a name, and an age. Now we could extend this parsing even further. For instance, well, first let's examine what we did. So an individual line of the file looks like this. Just a string. By stripping it, we remove that extraneous white space at the end, that new line character. And finally, by splitting on commas, we turn that string into a list where we separate out the elements on either side of the commas. Now we could extend this even further. For instance, we know that the index and the age are numbers. So we might want to do something like take that line, return an integer for the how shall we do this? Let's say this line all split up like that is going to be a row. And we might take the first element and cast that as an int. That's the index. Then we have the middle element, element 1, which is a name, and we won't do anything to that. And then we'll have, again, the age casted as an integer. And we don't want to do this casting for the first row, for the header. So we might say something like def parse row if row 0 equals index, return row, else return this parsed row. And we'll even move the line, call this parse line. So we'll even parse the line into this row list as the first step of this parse line function. And now, when we read in the file, we can just parse line. Also, we can iterate over the file handle directly. We don't need to iterate over read lines. So this is also a valid expression. We can just iterate over the lines in the file. And now we see we even have nice integer data in these positions. We could even build this up further by saying from collections import named tuple and create a row object with a index, a name, and an age. Didn't quite work. So now we have our headers, and each row of values is this named tuple with these different attributes. So we could, really build up the structure of this table if we wanted. But in general, we won't usually read in a CSV in this manner. This is a useful illustration for how parsing a text file might look and how we might construct a kind of generic data structure using whatever tools might be available to us. But as we introduce more sophisticated tools, particularly pandas data frames, which give us a tabular data structure, we'll usually rely on those for working with CSVs since they represent tabular data. So often, when working with CSVs, we'll work with pandas data frames, and particularly we will be constructing data frames using the read CSV method. I'm not going to spend too much time on the read CSV method at this time because I'm going to postpone that until we've worked more with pandas and have a better understanding of data frames. But just to advertise what's coming, here we had a bunch of code dedicated to parsing this CSV file into a meaningful data structure, and it's like 8 or 9 lines of code. Read CSV is a one-liner. It has many different options for handling different different variations of CSV files. For instance, whether or not we have a header, whether or not there's a column that should be interpreted as an index, whether the values are separated by commas or tabs or pipes or some other character. All these different options are available to us for parsing using the read CSV method. And again, I'll go through that in more detail in the future when we have a little bit of a better understanding of pandas. But just to show you what it looks like, pandas is able to very nicely parse that text file into this tabular data frame structure. And we can even deal with much more complex files. So here we're downloading a fact book about the countries of the world, things like their area, birth rate, debt, electricity consumption and production, all kinds of statistics about different countries. And despite the fact that this is a very large table containing different data types, we're able to easily read that into pandas using that read CSV method. Pandas also can write to CSVs. So here we've constructed a data frame by hand, and we can write that data frame to a CSV file and read it back in. So sometimes, while I'm not going to go too in depth about pandas at the moment, one of the reasons I wanted to bring it up was because since we'll often be relying on it to parse CSVs, one situation we have to consider is that not every CSV is going to be perfect. It's not always going to have every value. Some values might be missing. And anytime we're parsing a file into a data structure, we have to be concerned about how we'll deal with inconsistencies in that file, whether those are that's missing data or some sort of malformed text. So for example, here we have an example of a bad CSV where the name in the second column is inexplicably missing. Now, what happens when we try and read this in using pandas? It still reads it in, but there's a mistake here. It says the missing value is the age instead of the name. Sometimes we'll be lucky enough that even if there's a missing value, we'll have comma and then a second comma indicating that the name is missing from this row. But sometimes it's not the case. Sometimes the row is just short. In which case, we might end up with this kind of a situation, where we want the 54 to be in the age column and the NaN to be in the name column. So when working with CSVs, it's easy for problems like these to slip under the radar because though they're structured in that they use commas to denote the structure of the file, it's not a very strict structure. And so even if it's malformed because it doesn't have a fixed number of columns every row, it's probably not going to be a problem to try and interpret that into a data structure. Where it will become a problem is that data structure may have values assigned to the wrong cells. So just a word of caution about CSV files. Do inspect the data structure after you've parsed the CSV into it and make sure that the data is aligned correctly and has been correctly interpreted for your data structure. So I'll leave you with a question. How could we fix this badly formatted CSV file so that it would have worked when we read it in with read CSV? Though I'm not going to talk more about pandas during this lecture, you now know how to, you can run this cell over and over again and open up that bad CSV.csv file and modify it and see how it might change what gets displayed here. And again, when addressing this question, you shouldn't just simply add in a name. We don't know what the name is, but there is a way to alter the file such that you will get a NaN here and 54 will be placed in this age column. And that is the challenge I set to you. In the next video, we'll talk about another file format called JSON.